Anyways, the 2 out front means double y values. So 0, 0 is going to stay where it's at. This point pi over 2, 2. What doubles? The y value. So what's the new y value? 4. Might be similar grid up a little bit. We're going to have the point pi over 2. 4. Any change in the y values down here? That's pi 0. Any change? No. It's going to stay where it's at. I wish I had more room on the board now, aren't I? You guys have plenty of white space on that, don't you? I do not. So I got to move some stuff around. Let's see, there's pi over 2, 4. This guy had 3 pi over 2 negative 2. What's it become? I'll just keep funking with my head here, acting like you're stupid. Double y, it's negative y. 4. Can you change 2 pi 0? About 5 pi over 2. What's it become? 5 pi over 2, 4. And that point's right there. So here's the child. It's the same exact graph, it's just twice as tall. Might think of it as being twice as steep. That's the child. It's not hard, is it? Really not. Don't let it be. Of course, you have to know what the 2 out front means. You know, think of it as like a comparison. Well, of course, some of y'all couldn't graph it, but there were a lot of y'all that didn't graph y equals x correctly. But like, what's the difference between y equals x and y equals 2x? Is it twice as steep? Accelerates twice as fast upwards? No, it's about the same thing. All right, example B was to find f of parentheses 2x. That example B was? Huh? F of 3x? Oh, that stinks. I thought it was a 2. Bad. It's all about location. What is that telling you to do to the x values? About multiply by 3. Look at the transformation rule we wrote. This is multiply by 1 divided by the absolute value of 3. If it was in front of f, you'd triple y, but it's not in front of f, it's in with x. You kind of do opposite what it says. Now, think of it as a factor like 3x plus 1. You'd say 3x plus 1 equals 0. You'd subtract 1, divide by 3. You know, go back to something prereq that you've done. It's in that set of parentheses attached to x. You do opposite whatever it says. So we're going to multiply the x values. I forgot to write down x values. By a third. That's going to make this grid kind of fun. Take a pi over 2 and divide it by 3. Divide by 3, you do the multiplication in the denominator. You just put a 2 times 3 down in the denominator. What's pi over 2 divided by 3? pi over 6. So this point right here is still going to have a y value of 2. I'll make my grid bigger so it's easier to draw on this thing. But it's going to be pi over 6 instead. Pi over 6 is getting closer to the order. It's pi over 6. Now you do have a point here. You got to remember this guy. He was originally pi 0. What are you going to divide him by? Or what are you going to multiply him by? 3. And divide by 3. Or multiply by a third. So what was it? Pi becomes pi over 3. Isn't that a little bit before half? 1/3, a little bit before half. All right, next point of interest is a 3 pi over 2 negative 2. You've got to divide that 3 pi over 3, or 3 pi over 2 by 3. So divide 3 pi over 2 by 3. Or just take 3/2 and divide it by 3. Y'all can't do this, can you? Half. Well, that guy's about right there. Pi over 2, negative 2. 2 over 3, maybe? No. 2 over 3 would be a little bit to the right of the half. How about that guy? 5 over 2 times 30. Whatever. Oh, this is ridiculous. You know what I'm talking? Whatever. Half pi over 6, 2. Take 3, divided by a third, you get a 5. Right there. So there you go. Thanks for playing along. All I asked you to do was multiply the number by 1 over 3. All I asked you to do. You guys get together before class and say we're not going to talk today? All I asked you to do was multiply a number by 1 over 3, kids. That's all I asked you to do. Now that was actually what we call a horizontal compression. Because what did it do? It pushed the tail of this thing, didn't it? That's all it did. It's actually called a compression. It's not hard. It's really not. Here we have the reflection about the x-axis. What are mom's key points? Mom being y equals x squared. It was 0, 0. Negative 1, 1, 1, 1. There's this child's mom. Key points, by the way. Negative 1, 1. 0, 0. 1, 1. Child has 3 key points. It's just a reflection on the x-axis. And there's a negative in front of that x. The x values are going to stay the same. What's going to happen to the y values? It's going to become negative. Now, whatever I feed that thing, it instantly negates. It is a reflection on the x-axis. What you're supposed to do is you're supposed to realize that and use symmetry. Draw it. Or you can use tables. Whatever it takes you to figure it out. But if you see a negative in front of the x, and it's kind of funny how it's written, but like that is a reflection on the x-axis. Up next is probably a reflection on the y-axis. I don't remember what's in these notes. Ah, it is. Reflection That is titled incredibly wrong. That is a reflection on the y-axis. If I were a kid who had never seen transformations before, I would have a hard time distinguishing why this is an x-axis reflection and why this isn't. It's about location. The function here is actually x squared. This was actually y equals some negative f of x. You negated the function x squared, okay? The function here is the square root function. So this is actually y equals f of negative x. It's about location of the negative symbol. Is it inside a function or not? If the negative symbol is inside the function, it's reflecting on the y-axis. If it's outside the function, it's reflecting on the x-axis. This is actually something that reflects on the y-axis. One of the easiest things you can do is you can make a table. But we'll go ahead and we'll draw mom first. That's the root function. What was mom's 3 key points?
0, 0, 1, 2.
0, 1, 4 maybe? Correct? 0, 1, 2 on 1. Just take the square root of those numbers. Some people made up their own numbers. Why would you do that? Those are the 3 smallest things you can take the square root of. Plain and simple. Now, you know full well that you can't put in a negative 1 in the square root function, right? No, you can't do that. But because the new function is y equals the root of negative x, you can actually feed it negative values. Like, you're still going to feed it a 0. Could you feed it a negative 1? If you fed it a negative 1, that negative in front of the x would make it what? Positive. Could you feed it a negative 4? 0, 1, 2. It's just that the y values are part of the x values, you're having to be negative. You fed it negative values. So you can kind of see with the table and the graph, it's basically the same function. It just opens to the left. Now, if you don't know what to do, just make up a table and feed that thing. Feed it. Give it something to eat, and it'll draw itself. It will. Right, anybody got any questions about the reflection on the y-axis piece? And I'm just showing you with tables. I mean, that's how you truly understand this stuff, to make sense of it. I know kids don't like tables. This is kind of a cheat sheet on what to do. But I'm not going to go over the cheat sheet. All right, last thing in your notes, I think, is this one. Is there another one after it? Nope. Then a really funky looking one. Find the function as finally graphed after the following 3 transformations are applied to the graph of y equals absolute value of x. There's 3 steps here. So find its function. The grid there is kind of for you to draw as you go if you need to do that. I don't know what you need to do with drawing. But shift left 2 units. Let's see. What's our general transformation? Well, y equals a, f, b, x minus h, plus k. How do you shift left 3? Plus, sorry, I guess I shift left 2. How do you shift left 2? Plus 2, where? What do the h is? Because what's h stand for? Horizontal. Isn't it? Kind of one way to think about it. H is for horizontal. This would be y equals absolute value of x plus 2. How about the shifting up of 3? What letter is that? That's K. That's the one you trust. Remember that? Trust it. So just add a plus 3 at the end. Y equals absolute value x plus 2 plus 3. Reflect about the y-axis. There has to be a negative symbol introduced. Where? Is that absolute value? Where inside absolute value? Right inside absolute value. Yes. Now, I'm going to use TI-84 and verify that we're right. I actually have a question about what we did inside absolute value. I never liked doing reflections when there was more than one piece inside absolute value or any function. It always bugged me a little bit. So I have a tendency to go back and check myself. By the way, what we hope has happened here, if we think about what we did, the first thing we did is we shifted left 2. We drew a V over here, right? Then we went up 3, so the V got moved up here. Should look something like that. And the last thing we did is we reflected on the y-axis, which means our little V should end up over here. See, I actually do have a problem with what we wrote. I don't think it's going to do it. So I'm going to check it with the calculator. The reason I think we have an issue is because you're supposed to think of everything inside that function as kind of your x values. Right now it's just saying left 2. It's not actually doing what I want, but we'll check. So we have absolute value is under math, NUM, ABS, and yours might actually say ABS. This one actually opens up the bars. Oh, I'll be darned, it did it. Never mind, we're okay. Just a simple change on X did it. Because we could pull the negative out, that's why. So kind of check yourself, the reason I had that off the side was to draw what was going on, and I just checked myself with TI-84 to make sure the function I wrote did it. What's next? Probably the manipulation of this guy. Graph the function f of x equals 3 over x minus 2 plus 1. Do you know what the mother function for this thing is? It's actually listed. Yeah, it's 1 over x. So step 1's given to us. Draw mom. Mom's already drawn. There's a lot of little things going on here. We see this x minus 2 piece. What's that telling us to do? Go right 2. We see this plus 1 at the end. What's that telling us to do? Up 1. Now, there's also this 3 up top. Anybody know what that's telling you to do? What if it was... Mom was 1 over x, right? What happened to mom if you threw a 3 out front? She would become 3 over x, because of the location of that 3, what's it telling you to do? It's in front of the function, isn't it? What's it telling you to do? Can't hear you. Some masks. Vertical stretch, triple Y. That's all it's saying, triple Y. That's actually not a bad problem. It's really not. You're supposed to do this step by step by step by step, but just think about what it's telling you to do. You can do it all in one swoop here. To the right 2, draw that in, it helps. Up 1, draw that in. There's your new origin. So we had a point that was 1 up and 1 to the right of the old origin, which means it's 1 to the right and 1 up of the new origin. That should put it at 3. Actually, we've got to do some more stuff to it, don't we? We also have to multiply the y values by 3. That's kind of interesting here. Oh, what's this telling us all to do here? Should I do this with tables? So much stuff. If I were to triple these y values, this will become 1 3. This will become 2 3/2. And I don't even really care about that one. This will become -1 -3. I'll do the tripling first. So from this point, I actually have to go over 1 and up how many? 3. And then up about right there. From here, the old one was down 1, left 1. And actually go down left 1 and down 3. So I'm going to go to the left 1. I'm going to drop 1, 2, 3. That right down there. I'm not too concerned about the other 2 points on these things. And it's kind of ridiculous anyways. Because you get the same exact graph. It's still going to try and hit the new x and y axis as you go to infinity. As you get close to the origin, it's still going to approach it. And that's really all there is to it. That should be the last thing in y'all's notes. Huh? There's another one? I thought the next thing was homework of the book. I'll graph that thing. Okay, that's an easy one. What's mom? Where's X? What do you want to do, mom? Up to. Why did I do that? Why did I rewrite that radical? Makes the other shift more obvious, doesn't it? You can rearrange enough things outside of radical. There's nothing wrong with that. It makes the shift more obvious. It's +1. That's what I want you to actually do. Shift left 1. So y-axis moves back 1. You know, what this would actually do, what I've got so far here that I've kind of thought of, is that's y equals root x +1 +2. I have taken care of every shift except for what? where I've done everything except that last thing, that negative in front of x. What does that do to it? Reflects on the y-axis. So the final transformation looks like that. Look at my eyeballs. All right, so I saw some eyeballs wide there. Put 3 off. That's kind of a piece by piece. It makes for a very ugly looking graph. But what I did is I did the easy stuff first. I just thought about the initial transformation, you know, shifting up and left, and I drew it. And the reason I always do these dotted lines is because it makes it easy to do a reflection on the y-axis. This is my new y-axis. That is what I was supposed to reflect upon. Instead of opening left, instead of opening right, I open left. If you got a question, I'd be happy to answer it. Homework. By Brittany. Tomorrow is the day I got set aside for your project, kids. Hope you got something drawing. Seems like I lowered the requirements on equations down to 25. Let's do next Wednesday.